Hello, welcome to section B. This is 2020 November, HL paper 1. Section A is down below in the description. And this is a solution to section B. So let's begin with question 10. Look pretty tricky. There's a function with coefficient of a, b, c, d. Find the derivative. Okay, that's an easy part. 3a x squared plus 2bx plus c. And suddenly they say that the inverse doesn't exist. Hence, show this. Okay, this one is kind of it's a bit tricky. Okay, when does the inverse doesn't exist? Okay, the inverse doesn't exist when your function would go up and down. Okay, so let's say this is a cubic, right? So if your cubic look like this or this, all right, then they do not have an inverse. Okay, the reason is they're gonna fail the horizontal line test because that means there exists multiple x value that give you the same y value. So this is a many to one function, hence there's no inverse, okay? So you don't want this two to exist. You don't want, sorry, you do want them. Okay, it's the opposite. You actually don't want the inverse to exist, so you need these two cases. And in order for these two cases to exist, you need the graph to go up and down. Okay, so some part of the graph should be increasing, some part of the graph should be decreasing. Then that would mean that the derivative need to be sometimes positive and sometimes negative. All right, because when it's positive, that means the function is increasing. When it's negative, that means the function is decreasing. Okay, so you want the derivative to be sometimes positive and sometimes negative. And the derivative itself is a quadratic. So when is a quadratic sometimes positive, sometimes negative, that means look something like this, okay? Either this one or that one. All right, because then when it's above the x-axis it's positive, when it's below it's negative, okay? When it's above it's positive, when it's below it's negative. Okay. Now, if a quadratic look like either one of these two, what can you say? Well, the answer is that it must have two x-intercepts. And when a quadratic have two x-intercepts, that means the discriminant must be bigger than 0. So now you see the familiar b squared, and that's why there's a inequality. So this is not the first time this concept come up in an HL paper, but it is kind of tricky that it's just pop up like this. Okay, it could be, catch you off guard. So that, but now you know what to do. You do b squared minus 4ac. The b of this quadratic is 2b, so it's 2b squared minus 4a. The a is 3a. The c is c, bigger than 0. So 4b squared minus 12ac is bigger than 0. Divide the 4 away. We got 2i. Part B, consider the function g. So g is a cubic. Show that the inverse will exist. So it seems that we're using this condition to check that g inverse would exist. So for g, the value of b squared minus 3ac would equal to, what's the b? The b is the coefficient of x squared, so it's minus 3 squared. Minus 3 times a is just half. C is the coefficient of x, so it's 6. This is what? 9 minus 9. So it's 0. Okay? Now from the previous part, the inverse does not exist when this thing is bigger than 0. This is not bigger than 0. So So this is less than or equal to 0. Okay, it's not bigger than 0. Therefore, G inverse have to exist. And so we want to write Gx in this form. Okay, this is almost like completing the square, but for cubic. Well, but it's not a square, it's like completing the cube. But I doubt if anyone have learned a like efficient method of completing the cube, because even myself have not done anything like that. So I believe the best way would be simply expanding this formula and then compare with the answer to find P and Q, okay? So let's expand x minus 2 cube. We know binomial expansion, so it shouldn't be hard. Minus 3 times 2 plus 3x 2 squared minus 2 cube. So this is minus 6x squared plus 12x minus 8. So we need P times that plus Q to equal to the question. It should be obvious P of no choice but to be half. And if P is half, when P times minus 8, we have minus 4 at the back. All right. Well, actually, let's write out. So minus 3 plus 6. So they're all correct so far. Then minus 4 plus P. But I need a minus 8 at the back. So P have no choice but to be minus 4. P again, Q. I mean Q. The back number is Q, okay? Q is minus 4. Okay. Hence, find the inverse of G. So that shouldn't be hard now because of that huge hints they gave you, the fact that you need to complete the cube. As a matter of fact, if you want to find the inverse of a quadratic, then you should know that you need to do completing square. The reason is that you can cube root both sides. Then you can isolate x rather easily. And so G inverse, obviously we swap x and y. You could swap x and y at the beginning or at the back, or I mean at the end, doesn't matter. Like this. The graph of G could be obtained from doing transformations. So that's probably not too hard now. Take the transformation in the order that they apply. The G, okay, they want G, they don't want the inverse. Okay, G is, well, I don't have it. Oh yeah, I have it here. So the order is you do the 2 first, and then do the half, and then do the minus 4. Okay, so you should know that the 2 is a horizontal translation, while the outside 2 are vertical. Technically, the order of horizontal and vertical doesn't matter. You can do them in any order if one is horizontal, the other vertical. But for the vertical transformation, you have to do the compression or the stretching before the translation. Okay. In case you doesn't know, if your function is like a times bx plus c plus d, then a need to be before d. On the other hand, c must be done before b. So the order for horizontal and vertical is a bit different. So that being said, the transformation, I usually like to do horizontal stuff first, would be translate to the right by 2 units. and then vertical compress by scale factor 2, and then translate down. So down by 4 units. Okay, not the prettiest handwriting, but I think you got it. Sketch the graph, indicating the point where each graph crosses the axis. Okay. So let's do that. So this is, basically, this is how we're gonna draw G. Okay, so obviously you're expected to know that the cubic graph looks like this, and it passes through 0, 0. So we're gonna shift it to the right by 2 units, and then vertical compress, but the fact that you have vertical compress only make it a bit shorter, doesn't really show much, and then go down by 4 units. So 1, 2, 3, 4. So it should look something like that. Ow, I deleted what I want. Right there. Oh, that's gonna jump. What do I need to show? I need to show where the graph cross the coordinate axes. I don't think I can find that using transformation. Well, maybe I can, but doesn't bother. But I don't want to do it. For the y-intercept, I just make x 0. So that would be 0 minus 2 is 2 cubed. So it's minus 8 times up minus 4 minus 4 minus 4 minus 8. Okay. And then for the x-intercept, we have the thing equal to 0. That's a minus. Equal to 0, so this is x minus 2 cube is 8. Cube with that's 2. So x is 4. So it's 4. So that's the gx. Let's label it. Remember to label it. Label your graph. Y equal to gx. Then you'll reflect this graph along the line y equal to x. This is my y equal to x. So if I reflect it, the y-intercept of minus 8 will become x-intercept of minus 8. So that's quite far away. My scale is pretty bad, actually. Hopefully, would that be a problem? Okay, that's kind of a problem. Let me redraw it. The scale was bad. So 4 minus 8. So the graph is like this. This, and so the inverse, x-intercept is minus 8, y-intercept over 4, reflect, roughly like that. Not the prettiest graph, but that should do. Okay. If you listen to the section A, I said actually are getting easier. Maybe I should take that back. This is not a particularly easy question, but it's only the first question of section B. Let's see what's next. A curve, find dy dx. So it looks like implicit differentiation. So we'll differentiate both sides with respect to x. If we differentiate y squared, we do chain rule, so it's 2y times differentiate the inside. The inside is y, so you differentiate y, you get dy dx. Right hand side, differentiate the sine, differentiate side is cosine.
copy the inside, times differentiate the inside. The inside is x times y, so we need product rule. Product rule, copy the first, differentiate the y, plus differentiate the first thing, differentiate x is 1, and then copy the second thing. Okay, so that should be the derivative. We need to make dy dx a subject. That means we have no choice but to expand this, because otherwise we cannot isolate the dy dx. I put the x in front, y cosine xy. Okay, sometimes my mood of that particular day affect my video. I feel like I'm doing section B quite a bit faster than section A. I'm not sure. I mean, pause the video whenever you need to. Rewind, you know. And for section A, if I went too slow, I'm so sorry. But you know what to do. Everybody watch YouTube with 1.25 speed, right? So I'm sure you know what to do. So we got what we want. Prove that when the derivative is 0, y is plus or minus 1. So let's do that. Make dy dx 0. I hope this is not too small, but I really do need the space. So when it's 0, you multiply the bottom to the right. So those are gone. So you have y cosine x times y to be 0. So two things multiplied together to be 0. That means either y is 0 or cosine xy is 0. But the question do say y have to be plus 1 or minus 1. So it seems like y can't be 0. Oh yeah, that's the condition of the question. So this is rejected. Now we need cosine xy to be 0. Okay, that's a bit tricky. When is cosine 0? So cosine is 0 when you cosine pi over 2 or 3 pi over 2 or so on and so forth. So I guess we can use ... to represent that, because I don't think I need you to learn how to write solution of cosine in a general form. But if you really want to, those are the odd multiple of pi over 2. Okay, that would be the general way of writing the solutions to when cosine is 0. So now we only have the condition that x times y is those things. Now on the other hand, we do have the condition of this. When you sine x times y, you have to get y squared. Okay, therefore now if I sine it, so if I sine x times y, which is the same as y squared, therefore y squared, which equal to sine x times y, would be having a sine of all the odd multiple of pi over 2. Okay, for some n. Okay, if you look at the graph of sine, where are the odd multiple of pi over 2, right? It's here, here, so on and so forth. Okay, so when those happens, it will be either plus 1 or minus 1. So it's plus 1 or minus 1. So y squared is either plus 1 or minus 1. Obviously minus 1 is rejected because a square cannot be negative. So y squared have to be 1, but if y squared have to be 1, then y is plus or minus 1. Okay. This is also tricky. Okay, I'm really taking it back. This is not an easy paper at all, considering section B. And hence, find all the points where the derivative is 0. So the range of x is from 0 to 4 pi, okay. So then I'll go back to here. Okay. We did got the condition that x times y have to be the odd power of pi over 2, so it could be pi over 2, could be 3 pi over 2. But seems like I should go all the way to 4 pi, so I'll keep going. So the next is 5 pi over 2, 7 pi over 2. That's 3.5 pi. What's the next one? 9 pi over 2. That's over 4 pi, right? That's over 4 pi. We also have the condition that y is either plus 1 or minus 1. Okay? So that means x times either plus 1 or minus 1 would be those things. And so x would be plus minus. When you divide the plus minus, you get a plus minus, right? Would be plus minus those. Okay. Now technically the odd powers of pi over 2 includes the negative ones. Okay? Because we know cosine is even, so the negative one, you have symmetrics there. But then obviously the negative one divided by plus or minus 1 would give you basically the same set of solution. So it happens for this time, it doesn't really matter. Okay. I believe those are all the points. Well, at least those are all the x's that would give dy dx to be 0. But they said they want to find all the coordinates. That means they want the y coordinate as well. So let's do it. When x is pi over 2, obviously whatever true for pi over 2 will be true for 5 pi over 2. Because they are a 2 pi difference from each other. Then if we sine pi over 2 y, or 5 pi over 2 y, oh, 5 pi over 2. Now the question is just, should y be positive 1 or negative 1? Okay, because y only have two choices, either positive 1 or negative 1, in order for dy dx to be 0. Okay? But remember the left hand side of the function is y squared. No matter what choice of plus 1 or minus 1, when y got squared, it has to be positive 1. Okay? It has to be positive 1. So this y have to be whatever it should be, so that this whole thing should still give you positive 1. When you sine, it needs to be positive 1. Okay? And we know that if you sine positive pi over 2, you get 1. But if you sine negative pi over 2, you will get minus 1. Okay? So that means y cannot be minus 1. Because if y is minus 1, then this would never equal to y squared. Okay? Remember, y squared is always positive 1. So for this 2, y has to be 1. Okay? I'm really running out of space. Let me think. For pi over 2, it actually would give you the same result for negative 3 pi over 2 and negative 7 pi over 2, because again, those two are also 2 pi away from each other. So this is one group. Okay? And for the other group, the other ones, when x is 3 pi over 2, 7 pi over 2, negative pi over 2, and negative 5 pi over 2, then the opposite will occur. All right, because if you just sine 3 pi over 2, you get -1. But again, you shouldn't get -1 because the left-hand side is y squared. You cannot get -1. So this time you need y to be -1. Okay? So those are the points. So for these groups, the y coordinate is 1. And for this group, the y coordinate is -1. Wow. I'm impressed with this question. Okay, so in exam, to be safe, you better write all of them out. There's probably some easier way to write them. Okay, I'm not going to write them, but I guess writing them all is not that bad, because making sure your presentation, your fancy way of writing the answer would work is also not easy. So just to be safe, I will just write them out. Okay. This is actually quite a complicated question. Okay, take your time to have a good feeling of what just happened. But when you're ready, we'll move on. I think that's the last question. Yes, this is the last question of the paper. Okay. This one, okay, I take that back. D and E look kind of complicated. But the vertical asymptote of a rational function, that should be inside your basic knowledge. That's when the denominator equals to 0. So that's when x equals to k. Horizontal asymptote is the ratio of the coefficient of x. So it's k over 1, so k. Algebraically determine if f is self-inverse. Self-inverse simply means if you find the inverse would happen to be the original function itself. Okay, so let's do that. I will swap x and y at the end, but you can do that in the beginning. Since I'm swapping at the end, so I'm making x the subject right now, but if you have swapped from the beginning, you'll be making y the subject. If you have swap, y and k is the same as k times y. We'll divide it away. Therefore, the inverse. So at this very last step, I would swap all the y into x. That's way better. What that? Does it look like the original function? Yes, it's exactly the original function. Therefore, it is self-inverse. Okay. So far, so good. Consider the case when k is 3. Okay. Sketch the graph showing asymptote and point of view. Okay, D is easy. Very standard. So k is 3, so the vertical asymptote is at 3. K is 3, so the horizontal asymptote is also 3. We will need to find the x-intercept and y-intercept. What's the function again? It's 3x minus 5 over x minus 3. So if x is 0, y would be 5 over 3. So the y-intercept is a bit lower than 2. And when y is 0, x is also 5 over 3. Makes sense because it's a self-inverse. So it's like this. So the graph looks like this. And of course, it's self-inverse. You can see that the graph looks to be symmetric of the line y equal to x. So it makes sense. DE is a region. Oh, I didn't saw that. I thought I need to somehow make something like this, but turn out it is just a volume of revolution. Is it just me, or is the last question actually easier than the first two? If that is true, then keep this in mind if you're taking the IB this year. Maybe IB is changing its practice of making the most difficult question last. Okay, usually they put the question, this is 4, this is 5, 6, 7, in order of difficulty, but maybe they're changing that. Okay, the curve of fx, line 5 to 7. Rotate it through the x-axis, find the volume of revolution. I don't think this is difficult because there's a formula. Pi integrate from 5 to 7 y squared dx. I mean, although this might not be the hardest question in this section, it is certainly not easy to integrate this thing squared. Let's actually expand them. So this is x squared minus 6x plus 9, while the top is 9x squared minus 30x plus 25. So this is rational. If you have practiced this enough, it should be obvious what to do. First of all, the top power, the top degree, is the same as the bottom degree. Whenever the degree are the same or the top power is higher, you need to do a long division. Okay, that's part of your basic knowledge for integration. Well, it's not terribly basic, but you should know it. 54 plus 81. They are testing my mental math. Again, I hope I don't make mental math mistake. That will be embarrassing. Is there actually 24? Yeah, look at 24. 25 minus 81, so 81. So it's minus 56, I think. Like that. So the integral becomes 9 plus 24x minus 56 over the divisor over the original denominator. But that denominator was x minus 3 squared. So 9 is readily integrable. The problem is the next part. I don't think I have much choice but to do a partial fraction. So it's a x minus 3 plus x minus 3 squared b. This is one of the standard situations that you will see for a partial fraction. The fact that if the factor is squared, you need two partial fractions, one with power of 1, the other with power of 2. But even though this is a power of 2, the top is still just a constant instead of bx plus c. Again, this should be inside your basic knowledge. So a x minus 3 plus b getting common denominator. So substitute x to be 3. So 72 minus 56 equal to b. So we got b. And to get a, we can choose x to be 0 maybe.
So the left-hand side becomes negative 56 equals to minus 3a plus b. Well, we found b to be 16, right? So you minus that. That's like what, 82? So 72 negative. So that means a is positive 24, I think. Okay, so the integral becomes 9 plus, what's the partial fraction? A over x over 3, x minus 3, a is 24, plus b, so I'm copying this, b is 16, so this is readily integrable, integrate 9x, integrate this, 24, ln x minus 3, oh, this is already integrated, I shouldn't draw the integral sign, plus we integrate this as x minus 3 to the power of minus 1, so it's negative 16 x minus 3 minus 1, 7, 5, so it's 9, 5 times, 7 times 5, sorry, 9 times 7 minus 5, plus 24, log, if I plug 7 in, I got 4, minus plug 5 in, log 2, minus 16, plug 7 in, 4 to the power of minus 1, minus plug 5 in, 2 to the power of minus 1. So this is what, 18. When you minus log, you divide. So there goes the log 2. Minus 16, 1 over 4 minus 1 over 2, negative 4th. So that's 18 plus 24, ln 2 plus 4. So that's 22 plus 24, ln 2. So the form is pi times a plus b log 2. A, b are integers. I did got integers. I hope I get it right, but hopefully I'm not terribly wrong. I might make some mental math error, but I think the method is correct. So overall, E is not tricky. It's just a bit of a long working. I do still believe question 11 is actually the hardest question. Like conceptually, that's way more complicated and tricky. Okay, but this would be it for XL paper 1. I'll see you in paper 2.